Hello everyone, this is Meng Tian. So today I'm going to talk about the human robot teaming and make a presentation to us. So the first part of the presentation is the background of human robot teaming, and we are going to get through it from the past, the present, and the future. At first, we should know that the human robots teaming relates to robotics, artificial intelligence, and system engineering. I believe that everyone has used the ChatGPT and AI drawing or AI music in the past. So this is the first part we get through the human robot teaming as it is getting closer and closer to our current lives. So I'm going to talk about the background, and with the development of technology nowadays, human robot teaming is becoming a more and more popular topic. So, unfortunately, advances in technology and artificial intelligence have uh, catapulted people into a new era. Human and robots not only coexist, but actively interact to achieve hard tasks. This paradigm changes in human robot interaction gave rise to the concept of human robot collaboration, which relates to robotics, artificial intelligence, and system engineering. That's what I talk about. Human robot teaming requires human and robots work together to accomplish jobs. Some companies will apply human robot teaming to test their products, and some research teams will apply human robot teaming in their final verification, as if testing with human robot teaming, the result of experiments will become more accurate. And in the future, there will be more and more human robot teaming in the companies, in schools, or in just on the road. And the second part is concept development. For the concept development, we are going to get it through needs analysis, concept exploration, and concept definition. First, I'm going to talk about is the three threads in human robot teaming. The first thread is to create collaborative tasks that requires both human and robot skills. With the help of a standard jobs analysis structure, an authorizing environment is developed that enables engineers to articulate their manufacturing process. Once this process is specified, the tool assigns humans and robots in the best way possible, and it generates a human work plan and robot program that can test to simulation. The second part is concerned with collaborative tasks that are generated from the first thread, and human operators performed them. Human participated with cobot to determine the degrees of tasks in interdependence appropriate for collaborative assembly. To better understand how workers' performance and cognitive burden are impacted by attention aids, people also analyze a supervisory task. And the third thread is the different skill gaps related to the cobot integration. Uh, Recent ethnographic research revealed that cobots are perceived as traditional robots without limitations, rather than as tools for utilizing more advanced collaborative work paradigms. The emphasis of industrial robot training on traditional automation skills, concern for human safety, and ease of creation for automated, semi-automated solutions are factors for choosing a cage-free approach. The conflict between operators want to modify cobalt programming and engineers worries about potential safety repercussions further complicates the situation. Researchers are creating an educational environment that enables operators to securely learn how to program robots, comprehend collaborative robot safety, and comprehend the different business goals that influence programming designs in order to alleviate the strain, to better equip operators and engineers in the manufacturing industry. Researchers will investigate those three leads in more detail in future studies. And also, with the fast development of artificial intelligence nowadays, the job people need to do is becoming fewer and fewer. Robots and machines controlled by artificial intelligence can replace people to do a lot of dangerous works and also work on a longer time. Human teaming is the most original teaming, while the robot teaming is the most recent teaming. It both has advantages and disadvantages. Robot teaming will have an efficient but not accurate result, and human teaming will take a long time for the test result. That's why the human robot teaming is becoming more popular. And the first part is needs analysis. We will getting closer to needs analysis through the safety and reality. The first example is bombs and explosive robots. As we know that safety is what people need first while they are working, and robots can replace people to do some dangerous jobs. The bombs and explosive robots can find bombs and explosives through the camera, and also there are specific robot called mining robot for finding mines under the ground, and robot will be in a dangerous environment, and human will be able to analyze the data transferred from the robot and find the best way to react to the bombs and robots. And the second one is telepresence robots. While everyone is online, people will have the feeling of unreal. But if they change to robot and communicate with someone, will feel more reality than just chat online. For the telepresence robots, in comparison to visual teleconferencing or teleconferencing, these bots can make telecommuting commuting for employees more interesting and more immersive. Everyone has experienced the agony of trying to turn down during a video conference call or teleconference when two people try to talk, followed by quiet, then two more people try to speak, and so on. Given a distant person a physical presence in the space, while a telepresence robot can give the impression that they can present and offer visual signals that are impossible with voice calls. The second part is concept exploration. Human robot teaming will definitely become a developing trend. It is also needed to be considered that with the development of robots, it will replace more jobs than people can do, and it will have a large effect if one day robots replace people's jobs on most positions and people lost their jobs. what will be the result for the society. Third part is the concept definition. Human robot teaming defines as human and robot work together as a team to solve a problem. The application of human robot teaming is used widely in the space exploration or disaster response. Human robot teaming requires technology of hardware, software, and communication protocols to create the basic HRT system. There will also be simulation for testing both human and robot to make sure they can work together. Costs and benefits will also be important part for the concept definition. Initial investment and operational costs for human robot teaming will be analyzed, and potential long-term benefits should be make sure that it can cover the original cost. And the third part of the presentation is challenges. And we'll get through the challenges through 9 parts. The first part is communication. For the communication between human and robot, the frequency, modality, and content is important. For the frequency of human robot teaming, if there is too many messages for robot at one time, it might lower the situational awareness and cause poor decision making. It is crucial to take into account that the impact of communication frequency on workload, contextual awareness, and decision making. Researchers suggest to send message at a fixed frequency to give a time interval for the robot. However, according to certain studies, event-triggered communication can improve communication effectiveness. Effective balancing of the amount of information contained in each message and the frequency of messages sent and received throughout the task is necessary for efficient communication in HRTs. For modality, researchers studied two-way dialogue, multimodal communication, and visual messages, but they found that it increases mental workload and creates challenges to situational awareness. For the content, sharing experiences such as state, action, and task rewards trajectories has also recently been proposed, but with bigger teams such as experience shared system can become exhausting and present a significant communication and computational cost. A successful communication strategy should effectively summarize actions and include messages that are rich in information that may be used to make decisions while avoiding the dissemination of unneeded information. Second part is modeling human behavior. Understanding among team members is essential for effective teamwork. Previous studies in HRT has demonstrated a positive correlation between team performance and shared mental models between human and robot. This section discusses the difficulties of simulating the objectives and skills of human teammates. Learning the user's aim of the policy can help model user behavior by predicting the user conduct in various scenarios. Model-based and data-driven techniques to modeling human behavior has been investigated in earlier publication. Here we emphasize two major obstacles that robots emulating human behavior must overcome: complexity and suboptimality. Third part is long-term interactions. It will take a long-term time for human-robot teaming instead of a single moment. Furthermore, the interaction will repeat that will repeat that may take months and years, even lifetime deployment. There will be dynamic elements of the environment in each of the domains that HRT will be beneficial to, and necessitating the need for robots to continuously and intelligently reason over the streams of data. Additionally, it's crucial for the robot to comprehend a situation as interaction progresses by considering both past and present knowledges as well as future predictions to construct a collaborative plan. The fourth is scalability. Scalable HRT has challenges while modeling a bigger group of varied team members. According for changes in constraints of resource and using a variety to compute methods, the scaling issue that faces human and multi-robot teams also apply to HRT for coordination and collaboration, but they do not take into account the heterogeneity that has been incorporated. And the final one is safety. As we talked before, safety is one of the most crucial aspects for human robot teams because as human robot collaboration develops, the likelihood of safety problems will also rises. Collisions can cause catastrophic injuries in industrial settings where strong robots and human employees coexist. Similarly, the closeness of domestic robots to end users and the large population that coexist with present unique challenges for assuring safety. The safety issue extends beyond the two instances and affect all HRT uses, such as supporting astronauts, rescue operations, agriculture, and assist driving. And for the privacy, we outline two major issues with privacy in HRT. The first one is personalization in HRT, and the second one is maintaining domain-specific policies. The seventh one is ethics, finding the responsibilities of system designers, introducing transparency to increase robot trustworthiness, and emphasizing the necessity of building robots that supported diversity, equity, and inclusion are some of the issues involved with making ethical decisions in HRT. And the eighth one is metrics and benchmarking. While selecting matrices, measuring shares, mental model, and benchmarking of the challenges meted by it. And the last one is human psychological well-being. The sociality and robots replacement of humans will take into the consideration for the HRT. And so the first one is conclusion. Human robot teaming is one of the most intriguing and interesting advances in the field of technology. HRT represents the breakthrough fusion of human intelligence with machine capabilities, ushering in a new era of collaborative problem solving and productivity enhancement. By considering the safety, efficiency, and accuracy, the HRT will apply into more jobs and works in the future. And thank you for listening to my presentation.